Hello, my name is Steve Baker. I'm Managing Director of Baker Self-Adhesive Label Company. We've been a company that's been running for 47 years now, and we recently started BakPac as a division of this company.
Hi, I'm Phil Smith, General Manager of BakPac. Joined just over a year ago to help with setting up this new and exciting department, part of Baker Self-Adhesive Labels.
You might have just done this, Steve, but can you explain and summarise who Baker Labels and BakPac is, and what do you do?
Baker Self-Adhesive Labels, or Baker Labels as we like to be known as, is a trade label printing company. We've been established over 47 years. We've been working with the trade, mainly other label printers. That's our main bulk of the business. We don't really deal with end users. We've seen this as a very successful area of our business, and that's why we decided to establish BakPac with the same sort of ethos that we would supply to the trade. So other packaging companies or other label companies that wanted to get into packaging, because we see that this is potentially a good growth area.
And you recently acquired a solution from Empron, being one of your investments that you made for the launch of BakPac. Can you please tell us why you invested in an Empron machine rather than another supplier?
When we decided to start BakPac, we were looking for a digital solution. We knew which print press we wanted to purchase because we've been an HP customer for many years. And the difficult area was trying to find a laminating solution that would suit our needs. There was another one on the market, but we were quite green to this market. We didn't really, we understood thermal lamination, but we didn't understand the full lamination process. So when Mike Burton from ABG approached me to say that he was looking to have a solution for this, we decided to have a good look at his solution. Mike has always been a fantastic supplier to Baker's. We 100% trust him and we trust his judgment. So when he said that he had a good solution, you know, it was wise for us to listen. We went out to see Empron in Spain and was very impressed with the quality of the work that they had. So the combination of ABG and Empron made it a very easy decision for us. And we're very happy with the result. It's very high quality workmanship.
We know that the flexible packaging market is growing, as is the pouch market. Why did you choose digital printing and thermal lamination for the pouch market instead of the conventional system?
We decided to set up BakPac because we could see that there was a big growth potential in digital flexible packaging. Having digital flexible packaging means that, or a digital printing process means that you have to have a laminating process that can deal with short to medium runs, minimum setup, minimum waste, fast turnaround. So thermal lamination seemed to be the obvious choice to us. We didn't want to be involved with solvent or solventless where there would be fluids involved. We wanted a fast system, a system that we didn't have to have any waiting time after any post-cure time. We wanted to be able to offer a service where we could actually get artwork in the morning and produce pouches in the evening, which this system gives us.
Phil, can you please tell us about your experience so far in terms of functionality and ease of use?
The experience has been very positive so far. The Empron machine has proved to have great functionality in terms of controlling web tensions and temperatures, which are the key part of thermal lamination. The training of the staff has also been a very straightforward process. There isn't a vast amount of technical knowledge that you need to build up to run a thermal lamination machine, and the way that the interface of the machine is designed makes it very easy for operators to learn fairly quickly how to control all the key parts of the machine.
Please can you tell us about your experience with speed and performance?
Speed performance has been exactly where we need it to be. The engineering of the machine is based around wide web conventional lamination, so it'll always be able to cope with the speeds needed for thermal lamination, which are slower than conventional. And the results that we've achieved have been very good and very stable. So we achieve between 5 and 10 newtons generally on the tensile testing that we do, and the results are achieved instantly from the end of the machine. So there's no post-cure process. We don't have to wait for a couple of days to do our QC testing. We literally stop the machine, take a sample, do a tensile test, and know instantly whether we've got a pass or fail.
Steve, with your experience to date, do you think this is a scalable product in terms of additional presses?
Absolutely, in terms of how many digital presses we can invest in and the Empron still be able to cope with it. Not such good news for Empron, because obviously I can't see us requiring another machine for many, many years, because I think this could easily cope with 3 HP presses very easily. It's for what the amount of usage that we require of this machine with only 1 press at this particular time is very minimal, and the fact that it runs so well, the jobs are on and off before we have a chance to print the next one. So yes, definitely we could have several printing presses, and this one laminator will cope with that.
So to finalise, can you show us the thermal laminator?
This is the thermal laminator.
This is the Empron thermal lamination machine. So the thermal lamination process is where we take the printed web and a thermal lamination film and bring the two together using heat and pressure. The thermal lamination film has a tap layer on it, which is a thermally activated polymer, and both the lamination film and the printed web unwind from this section of the machine, from opposite sides of the machine. They pass through chronotreaters, 2 chronotreaters, to treat the printed web and the tap layer, that thermally activated polymer. Both the webs pass over to this side of the machine, where we apply heat and pressure to bring them together. So the printed web is passed through a preheat roller where we run at about 50 degrees, and the lamination web runs over the hot roller, which runs between, say, 100 and 120 degrees. As it passes that roller, the tap layer is melted, and then the 2 webs are pressed together through the nip rollers, bringing them nice and bonded together. After that, they go through a cooling process where they're brought back down to around about room temperature, which helps to set that tap layer, which is very important because we want to be able to do our QC checks very quickly. Once it's been through the cooling process, it then comes to the rewind side of the machine, where we can stop the press, take a sample, and run our tensile testing. If we get the results we want, we're good to go. If not, we can make some small adjustments to either tensions or temperatures and run a small test again using very small amount of meterage, take a sample, do the test. If we get the pass, then we're good to go. So a fairly basic process, but a very well engineered piece of equipment that controls the web tensions very well. We're running thin webs of polypropylenes, polyesters, polyethylenes as well. The heat control and the operator have got a very easy access to control all of those elements through this main touch panel here. So that is the Empron machine that we use for our thermal lamination process, which to date has been very successful.